A warm greetings to everyone. This is Revan from the Department of Success and Design. Now we are going to see the introduction of my design. The conclusion is the bracket. A bracket structure is a fundamental component widely used in engineering and construction to provide support, stability, or connections between two parts of a system. These structures are typically designed to bear loads withstand stress and ensure the safe transmission of force without failure. Now I am going to see show my geometry and design. Here you can see the my geometry details. Inner diameter is the hole which is given. Inner diameter is 20 mm and the lug thickness is 5 mm. I can clearly visibly count, but the fillet radius is 30 mm, which is shown on both ends, top and bottom. Uh, the length and height both will be 100 mm here. I can show we observe that. Now yeah, you can see the boundary conditions, pressure applications, and material properties. First, we are going with the boundary conditions. The boundary condition fix one end at a bracket to simulate a rigid support or planning. Use symmetric of if applications to reduce computational effort. Apply boundary conditions for displacement. Zero displacement in the x and y direction at the fixed end. Now we go to with the second one. The second one is a pressure application. Pressure for pressure application, P1 is and P1 to both are given, which I give 1000 kilopascals. For the material purpose, material is a steel and properties of materials you can see Young's modulus, which is given E is equals to 207 GPa, as well as Poisson's ratio 0.33, and yield strength is 250 MPa. Now I'm moving for missing details. Here you will clearly visible. You will observe that mesh type it is a quadrilateral mesh. Fine mesh for accurate stress analysis. Meshing specifications are total number of mesh. Total number of elements is a 445, and as well as the element type is a of four node quadrilateral. If elements, you can see elements mesh refined at the critical regions such as the hole and fillet, ensure ensure better convergence and accuracy in stress predictance. Can move down to comparison of a mesh. Here you can see clearly visible and can see that the comparison of between Abacus mesh and MATLAB mesh. Both results are extract here. Those things these are the same. Mesh of model at right side is a mesh of model at MATLAB from MATLAB. Left side is Abacus mesh. Um, this MATLAB I get from connecting code which I get and file and Abacus, and then we are moving for procedure to solve coordinated element for bracket structure in Abacus. Define first thing, define the geometry. First, you have to design 2D geometry on of the bracket, like outer diameter, inner hole, fillet radius, and thickness. Ensure proper scaling and dimensions. For the material purpose definition, define the material properties like Young's modulus, Poisson's ratio, and density. Assign the defined material to the bracket part. Now, final thing is meshing. Meshing, choose a four-node quadrilateral for meshing purpose. Element type, example, CP4R for 2D plane stress. Apply a fine mesh. Ensure refinement around critical regions. Example, near the hole and fillets. Verify mesh quality and check for element destructions. Now, boundary concerns. Yeah, while going for boundary conditions, mm, uh, fix one end at the bracket to simulate a rigid construction connections. Use symmetry conditions of applicable to reduce the computational cost. Okay. For analysis setup, select analysis type and static. Go with a static for linear elastic behavior or non-linear for plasticity. Use properties for appropriate solver settings. Step size and number of increments, convergence tolerance. Now the results and post processing purpose. Um, visualize stress and strain counters, identify critical regions such as the maximum stress around the hole or fillets, validate displacements and the reaction forces at the boundaries, export data for the further analysis or comparisons, and then go to results. We can see here results uh, like a stress, displacement, and strain. Uh, First thing, uh, for the stress results, okay, wine more stress, like normal stress at x and x, normal stress y and y, and say shear stress xy. With, further the displacement results, displacement in x direction at u1, displacement in y direction at u2, and as well as strain results. Can here see here normal strain e11, e22, e33, like shear strain and xy. Now we are moving to wine, like here clearly observe that wine masters. This is a mesh animation part. You can see here. Uh, this is a mesh animation part. That blue thing is a minimum. That is red one is the average thing. Here we can. This is the Abacus standard learning edition. You can you can compute these results from, you can extract this result, exactly compare with these things, as well as normal stress in the x direction also. Here we can see that this is a normal stress in x direction. These are the here here stress will be occurs between maximum between both holes, and here clearly visible and clearly observe that blue one is a minimum thing and red one is average. Now we are going to normal stress at the same time. Normal stress in y direction. Here clearly observe at y direction it will be show what the same results will compute. So you can observe that here. Now I am going to shear stress distribution. Here we share for the shear stress distribution the range from up to from 6 to plus 7, minus 6 to plus 7, and show. Now I'm going to displacement in x direction at u1 results. This is also same, but here shows the red region is up to 1.1 from minus 4 to 1. I mean, what we exactly seeing, observe in this. Okay, now go to the displacement in y direction u2. These are results, animating results, which I give after giving impact pressure, which I get. Uh, these things are these things are, this one is a blue thing is a as a minimum. This is a maximum. You can extract. You can see this. Then go to this. This one is also as well as strain in x direction. Can clearly visible, and I observe that we can observe as well as this thing also same. Uh, Minus from minus 4 to plus 6. And now we are moving to as well as same time strain in y direction only. Here we can visible from the results are computed from minus 4 to plus 4. Here we can observe that these things are these regions will occurs very more on these observe opposite way directions. Yeah. Now these are the state strain distribution. Here observe the figure, animate figure. The mesh will be the figure will be extract from above both ends. They are clearly visible. Okay, this is the final output my about my structure bracket. Now I'm going to conclusion. Abacus results for bracket structure. The analysis of the bracket structure using Abacus shows consistent and reliable results for displacement, stress, and strain. Stress distribution and strain behavior are well computed with the maximum stresses occurring at the critical areas of the bracket, which align with the expected failure regions. The displacement results show that the bracket structures behaves within the allowable limits, demonstrating sufficient stiffness to handle applied loads. This is my final output of this project, and thank you. Yes. Yeah.